So let's continue on talking about that database and database security. Now, a refresher on databases. A database is a structured collection of related data. You may hear it called a relational database, hence related data. You have relations between the tables that you may have inside of that database where all the actual data is kept. Now, databases or relational databases, they allow for queries where you can ask questions against the data and say, well, I want data just from a specific time frame or that meets this criteria. And that's the answer that you're going to get. You can pull certain data out of the tons of data that you may have. You could have insertions where we could put data into the tables. We do this all the time with our web applications. Deletions. You could remove data out of your database. And there's all kind of other functions that we're not necessarily going to get into, but just know that we can query, we can ask questions against that database and insert and modify, delete information in there as well. Now, the database is managed by a DBMS, a database management system, and that controls the access to the database and enforces our database security. It will also help with our database integrity. Now, databases are usually managed by someone we call a DBA, a database administrator. These are the folks that run our DBMS. They are the ones that we are going to go to for database issues. They're going to make sure that the integrity is there. They're going to make sure that the security is there for our databases. Now, they may take care of the server, the physical server. They may just take care of the database itself. They may just be responsible for a certain area of the database, a certain table. Depends on the organization and their security requirements and their policies. Now, databases may be searched with database query language because remember, we said we could ask questions against that database to get that information out. What we can use is a structured query language, SQL. And we could have different statements in there like select statements, insert statements, drop statements, things like that to manipulate the database. Now, typical database security issues, they include confidentiality and the integrity of the actual stored data. Databases are the main target, pretty sure I can safely say that, are a main target of attackers, of hackers. That's where all the good stuff is kept. If you have a web application where you're collecting tons and tons of data, first name, last name, contact information, addresses, social security numbers, credit card information, siblings, spouse information, blood type, date of birth, mother's maiden name, family info, all kinds of stuff, right? That's what they want. That's what they want to go for. So it's extremely important that we lock down our databases, lock down those tables and the data that's inside of there. Integrity is a primary concern when replicated databases are updated as well. Because you may not only have one database server and all your data is on there. Okay, great. What happens if that database server goes down? Now your web application's broke, you can't service your customers, you may have data loss, depending on what kind of crash it is. So we usually have more than one database server. May have two. And if we have two, they need the same information for that redundancy, that fault tolerance inside of our infrastructure. So we'll take all the data off server A and we'll replicate it over to server B. But we need to make sure that integrity is there, right? We don't want any changes between server A and server B. And then that goes back to confidentiality of how we're protecting the privacy of that data while it's being kept on those database servers. Now we also have something called configuration management. Monitoring and managing changes to a program or documentation is configuration management. Now the goal of configuration management is to guarantee availability, integrity, and usage of the correct versions of all system components like our software code, design documents, other documentation, and control files. So reviewing every change made to the system is in our configuration management. Anytime we make a change, it's there. Now, this is not change management. That's what we had before the configuration changes. This is configuration management. So in reviewing every change is made to the system, we're going to do identifying, controlling, accounting for, and auditing all of those changes. Now, this is intended to eliminate confusion and error or errors brought about by the existence of different versions of documentation, hardware, or software. So this way we know, again, we're all on the same page. We don't have this confusion. Well, this is not working like this. You told me it works like this, and it does work. I'm looking right at it. Mine works this way. Well, you got different software versions. There's confusion there. There's errors that could occur because you're not on the same page. Or you're on the phone, or on an instant message meeting, or a virtual meeting. You're looking at documentation. Well, the project says it, and somebody else they're flipping real fast. They're looking for that. They don't see that. There's more confusion, right? Because we don't have the same documentation. Configuration management is supposed to help alleviate those issues when it comes to that. Now, a little bit about code repositories. Let's say we are software developers and we create all this code. Where are we keeping this code? Are we going to develop this application and that's the only place it is? Or if we have object-oriented programming where we develop it in little modular sections, are we keeping that on our desktop? Are we throwing it over on our removable hard drive, or just storing it on a USB? We'll use that later, right? Or are we going to have some type of repository where we could put this information? Well, we want some place to put this information, all right? You can have one in-house. I'm going to show you one from GitHub. I thought it was outstanding, and I want to show them as an example, but you have to think about, is your code secure? If it's not, if somebody can get to your code, they may be able to reverse engineer it or understand what you've done and look for vulnerabilities, which is very dangerous for you, because I don't have to hack the actual application now. I've got the underlying code. I'm one step ahead of the game, and all I have to do is be able to scrub it and go through and find vulnerabilities. As soon as I do, nobody else has found that. Now you're going to be introduced with what we call a zero-day exploit, because nobody knows about that. You don't even know about the vulnerability. Now there's not a patch. There's nothing to fix that vulnerability. All I have to do is come up with an exploit, and I could probably do that if I can understand your code from your code repository. I'll come up with an exploit and take advantage of that vulnerability. And that could be detrimental to your organization. So make sure that the code repository is secure. Major one. Think about where it's located. Do you even know where it's located? Well, it's cloud-based. Okay, great. It's in the cloud. It's stored on a server somewhere. Who has access to that data? Who can get to that server? How secure is your data center? These are things that you really need to know, especially if you're putting applications, codes for projects that really affect your organization. So, like I said, while researching for ideas for this, I actually came across GitHub's code repository security outline there that they have right there on their webpage, and it's outstanding. It paints a great picture of secure repositories, and I want to share that with you. So this is their security. First, they talk about their physical security. Like I told you, who has access to this repository? So their physical security, their data center access is limited to data center technicians and approved staff only. So they do have some access control when it comes to their physical security. They have biometric scanning for controlled data center access. Okay, that is outstanding, right? They have accountability there now. They have identification, and they're using that for authentication, for using biometrics. They have security camera monitoring at all data center locations. So again, another security control. Security cameras could be a deterrent, and it could be detective. They have 24/7 on-site staff providing additional protection against unauthorized entry. Sounds to me like a fancy way of saying a security guard, right? So another deterrent. Unmarked facilities to help maintain low profile. So they don't go put a big logo on the side of the building. They don't, have all this bells and whistles around there when it's not necessarily needed for this data center. That way they don't stick out like a sore thumb and be like, hey, that looks like an important building over there. Maybe we got to go check that out. Maybe that's something special. Just kind of keep a low profile. They have physical security audited by an independent firm. So they're not even doing it themselves. They haven't somebody from the outside coming in doing that auditing. And that's just their physical security. They also have system security. They have system installation using hardened, patched operating systems. They have a dedicated firewall and VPN services to help block unauthorized system access. They have DDoS, or distributed denial of service mitigation services, powered by industry-leading solutions. So they have a way of protecting their own systems. So they have, so far, pretty good defense in depth. They got physical security. They got system security. They have operational security. Their primary data center, as they have listed on their website, operations are regularly audited by independent firms. So again, they're bringing in third parties. They're not auditing themselves. I'm not saying that's bad, but you get a better picture from third-party auditors. System access logged and tracked for auditing purposes. Secure document destruction policies for all sensitive information. So talking about document destruction policies, getting rid of their documentation, the shredding that we talked about. Fully documented change management procedures. Sounds kind of familiar, right? We just talked about change management. So they have them documented so they know what has been done, when they've done it, who's done it, what team approved it, who came up with it, things like that. They have software security. They have a team 24/7, 365 that are server specialists to keep software and its dependencies up to date, eliminating potential security vulnerabilities. Employ a wide range of monitoring solutions for preventing and eliminating attacks to the specific site. So they have more software security. Their communications. So all private data exchanged with GitHub, in this case, is always transmitted at least over SSL. All pushing and pulling of private data is done over SSH authenticated with keys or over HTTPS using yours as the client, your GitHub's username and password. And it works pretty well. I've used GitHub before. The SSH login credentials used to push and pull cannot be used to access a shell or the file systems. So all users are virtual, meaning they have no user account on the machines. And since they're virtual, access controlled through peer-reviewed, open source Git shells. So far, makes me feel pretty good. Their file systems and their backups. Every piece of hardware they use has an identical copy, ready and waiting for an immediate hot swap in case of hardware or software failure. So they're at the ready. And they've got staff there 24/7, 365. So they're always manned. Somebody is there that can do this, they're just waiting for something to go wrong. I know that sounds kind of morbid, but they're waiting for something to happen so they can jump into action and take care of their customers. Every line of code they store is saved on a minimum of 3 different servers, including an off-site backup. So they've got them on 3 servers, redundancy, built in their file system, and they got a backup off-site in case something happens to that whole facility. Outstanding. Their employee access. All right, so they're still talking about, earlier I said, who has access to our data. No GitHub employee ever access private repositories unless required to for support reasons. Now, staff working directly in the file store access is compressed database Your code is never present as plain text files like it would be in a local clone. So support staff may sign into your account to access settings related to your support issue, and in rare cases, staff may need to pull a clone of your code, but that's only going to be done with your consent. So they have policies in place for the employees on what they can and what they cannot do. They protect the login from brute force attacks with rate limiting. So all passwords are filtered from our logs and are one-way encrypted in the database. So they're hashed out inside of the database. Login information is always sent over SSL. We also allow you to use two-factor authentication as an additional security measure when accessing your GitHub account. So we can have two-factor authentication. We could use a username and password and biometrics or a token or a smart card. All right, outstanding. This is great. And then credit card safety, right? Got to think about that PCI. When we sign up for paid account on GitHub, they don't store any of your credit card information on their servers, which is a pretty smart idea on their part because they don't want to be necessarily, I guess, responsible for that type of data. They have enough on their plate right now when it's dealing with being a code repository, because they may have code for some very sensitive data, very sensitive programs, very sensitive applications. So what they do is they hand off to a third-party company dedicated to storing your sensitive data on PCI compliant servers. So they don't handle the credit card part. They pass that off. They're transferring that risk, right, off to somebody else in this case. Now we also need to talk about an API, Application Programming Interface. Now, application programming interfaces are the connectors for the Internet of Things, IoT, you might see it, allowing devices to talk to one another. APIs, however, can be plagued with security problems without proper coding. But we see these all over the place with APIs like, what's a good example? Okay, using your smartphone to control your thermostat, right? There has to be an API in the way that thermostat's programmed so you can talk to it. All right, so that's just one example of an API, Application Programming Interface. All operating systems have this. Microsoft's actually gotten some trouble over this in the past about being, monopolistic about their operating system and no competing and stuff like that. But this is how our devices they can communicate. We have to have these APIs in there. It's like with no APIs, I think I saw a reference. It was like somebody said it would be like building a house with no doors, right? So you could make an application, but nobody can communicate with it, right? Got to have those APIs. Now the problem is usually not the concept behind the API because, well, like we said, they're almost necessary, but how it's coded. You know, it always goes back, I'm not a software developer, but I know software developers, they get a lot of flack as far as their coding practices and how fast they need to get it out and go, right? But I'm not trying to take a hit at you again, but this is the API problem is how it's been created. Now, many application developers are failing to write or use APIs with security in mind, and that puts the application, because the API is how you can get into the application, and it's putting the data at risk as well. Again, the security may not be the first focus on their mind because they're thinking about speed, functionality, usability, efficiency, effectiveness of this application. Security is not just in development, but it's an afterthought in a lot of people's lives, and that's what we're trying to change, right? How could we help mitigate these problems? Application, programming interface problems. We could have fuzzing, right? Throwing a bunch of data out there. We could do penetration testing, right? We could do vulnerability testing, which is, part of a penetration test, but maybe we don't want to do a penetration test. We just want to look for the weaknesses, see if there's any weaknesses. We could take it one step further, like with a penetration test. We could also do manual code reviews. Those are all pretty good ways to help mitigate most of the API issues. Now let's talk about the excess of effectiveness of a security software, like auditing and logging of changes, risk analysis and mitigation, and acceptance testing. So auditing and logging of changes. Logs are the primary record keepers of system and network activity. We mentioned that earlier as well about not having auditing or proper logs in place. And if we don't, we can't see what's going on. We can't get in there and use them as a detective tool. So when security control experience failures, logs are particularly useful in capturing, recording the pertinent information that's going to help us understand what has happened, why it had happened, when did it happen, who may be responsible, what got affected. All of these questions somebody's going to have, and they're going to turn to us for the answers. We're going to need these audits and loggings of these changes that take place in our IT systems, in our network activity, in software development. We have to have these in all places, everywhere we can. We can also do the risk analysis and mitigation. Now we know risk is defined as an event that has a probability of something occurring. Remember earlier, way back in chapter 1, we talked about risk and we talked about the likelihood of something happening. So all projects assume some element of risk. We know there's going to be that, what they call inherent risk. And it is through risk management where we're going to get the right tools and techniques to apply so we can monitor and track those events. We want to track those events that have the potential to impact the outcome of our project, what we're working on as our team. Now, risk management is an ongoing process that continues throughout the life of the project. It's not something that we just do at the beginning and say, oh, we're good. We want to do it throughout the project to make sure that that risk is minimized, when little risk as possible. Mitigation, that's to lessen our risk, right? That's what we want to do. We want to take that risk. We know it's there, but we want to mitigate it, get it down to the lowest levels possible. Then we could do some acceptance testing. Acceptance testing is a formal test, and this is conducted to determine whether or not a system satisfies its acceptance criteria. Now, it also enables the customer to determine whether or not to accept the system. So it's kind of like we're taking our project that we've developed and we're kind of parading it around, right? We're taking it down the catwalk here and we're seeing if it's going to be accepted or not by the customer. Now, this test could be designed by the customer. If not, the customer is going to have some input because it's going to be geared towards the customer's needs. So who knows better about acceptance for something that you've designed it for than the customer themselves? So they're going to go through the project and run through and say, well, it meets this need, it meets this need, it meets this need. That looks pretty good, I accept it. So usually this testing is exact or very near exact replica of the environment that it's going to be intended for. So we'll take this project and, like I said, walk it down the catwalk, but what we're doing is putting it on a system, putting it on a network, putting it in the environment that it was intended for. And then the customer can go through and see how it behaves, see how it acts, see if it's doing, again, what we designed it to do. Check the logs, check the audits, make sure it's doing that. Do a vulnerability scan. Go through the whole gamut to make sure that we get the thumbs up and the stamp of approval. And then finally, we need to talk about acquired software. This is software that, well, we just go get. We may not have developed it ourselves. We didn't bring it up from scratch, maybe something already out there that we've just acquired. Could be from different things, acquisitions, mergers, just buying it straight out from somebody. Somehow we've acquired this software. We want to ensure that a well-documented software assurance policy and process is in place in the enterprise before we do this, so we can make sure that we're getting the right thing. We don't want to acquire some software and introduce a ton of vulnerabilities into our environment, putting our organization, putting our data, putting our customers, putting our reputation at risk. It's not worth it. Now, US-CERT, I went to their website and I looked, and they've got some phases out there as well that they go through. They have a planning phase, a monitoring and acceptance phase, and a follow-on phase. The planning phase needs determination for acquiring software services or products. It's going to identify potential alternative software approaches and identify risks associated with the alternatives of the software that we're trying to acquire. Also in the planning phase, we have developing software requirements that are going to be included in work statements. They talk about planning phase also has a creating an acquisition strategy or a plan that includes identifying risk associated with the various software acquisition strategies. And then finally, developing the evaluation criteria and evaluation plan. So you can see through this planning phase, they're taking care of a lot of things. They're trying to get their ducks in a row here before they move forward, right? They need a needs determination. Well, is this even necessary? Do we need this software? You know, he says we need it or she says we need it. Well, let's do a needs determination. We're going to put these in our work statements, create a strategy on how we're going to acquire this, and then make sure we have an evaluation plan in place. Then we'll go through monitoring and acceptance phase. So we've planned out why we need it and what we're going to do. Now we're going to go through this phase, which involves monitoring the supplier's work and accepting the final service or product delivered under maybe a particular contract. Now there's some major activities that are taking place in this acceptance phase. First, we're going to establish and have consent to the contract work schedule. So we're going to establish that work schedule of what we expect and what they expect. We'll talk about implementing change or configuration control procedures, and then the reviewing and acceptance of software deliverables of what they're actually delivering to us. So we're going to monitor and make sure that they're staying on track, staying on that work schedule. All right, yes, we want to acquire this software. We need this by such and such time, such and such date. So that's the monitoring. And then once we get that, we can review and accept the software deliverables. That's the acceptance part of the phase. And then follow-on. Always have follow-on or always have follow-up, right? This involves maintaining the software that we have acquired. We brought it into our organization. So we want sustainment, disposal, or decommissioning if we don't need the software anymore. During the follow-on phase, software risks need to be managed through continued analysis of the assurance case and should be adjusted to mitigate any changing risks. So we're always going to be looking at risk analysis and again trying to mitigate that. We're trying to lessen the risk and mitigate that risk to our organization. Well, that takes care of domain 8. So what we covered in this domain was the software development lifecycle, the SDLC, our development environments, software security, and finally we wrapped it up with a discussion about that acquired software we could bring in to our organization.